Hi folks, welcome to B&B Laboratories again. This is Mr. B doing the demonstration, and that is Mr. B doing the camera work. Today we're going to talk about relative humidity. Now, relative humidity is the amount of water vapor in the air compared to the amount of water vapor the air can hold at a particular temperature. Warm air is able to hold more moisture than cold air. That's why we always talk about it being hot and humid and not cold and humid. Cold air doesn't have as much room around the air molecules, so it can't hold as much moisture. So back to relative humidity. Relative humidity, the amount of water vapor in the air compared to the amount the air can hold at a certain temperature. So whatever this temperature is, this is 250 milliliters and it's in a 1,000 milliliter flask. So 250 compared to the 1,000 means that this would be 25% relative humidity. As your temperature drops, the air will be able to hold less because it's going to be colder. So now we have 250 milliliters in a 500 milliliter flask. This is going to represent 50% relative humidity. If our air continues to drop, the capacity for that air to hold water also drops. Now we have 250 milliliters in a 250 milliliter flask. So this temperature held 1,000. This temperature could hold 500. This temperature can only hold 250. We're at 100% relative humidity. We say that the air is saturated. Now, if the temperature drops, what happens to that extra moisture? It won't fit in the air anymore, which means that once you get past its capacity, it starts to come out. It gets squeezed, literally squeezed out of the atmosphere by the air molecules. Where does it go? It becomes a cloud. It becomes fog. It becomes dew or frost or rain or sleet or snow, depending on the temperature and where in the atmosphere this is happening. As it starts to warm up, this capacity starts to get better, and all of this moisture goes back into our atmosphere. So that is relative humidity.